So this is video number 6 on the practice final. We're starting with question 34. Now, ladies and gentlemen, factoring completely. What was the first type of factoring that we learned, Eduardo? What's the first type of factoring we learned? GCF. So when we look at all three terms here, what's in common? Well, let's look at the coefficients first. 36 and 54 and 18. There is a multiple of 9, absolutely. So let's put a 9 out here. But there's also variables that are in common in all three terms. So when we look at the first term, we have j to the 4th, we have j to the 9th, and we have j to the 4th. So what's the maximum amount of j's that we could pull out from all three terms? From all three terms, we could pull out a maximum amount of 4 j's. So we're going to put j to the 4th on the outside. Now we also have k's. Do we have k's in all three terms? We have a k here, a k there, no k over there. So we can't pull out k's, just j's. And so the GCF really is 9j to the 4th. Are you with me? Yes. Now what's left over on the inside? You're going to go 9j to the 4th times what? Gets us 36j to the 4th k. Once again, 9 times 4 is 36. So we can put a 4 on the inside. And then j to the 4th times 1 is j to the 4th. And of course, we need a k here in order to produce that k up there. So 4k is our first term. The second term, 9 times what is negative 54? That would be a negative 6. And then the j to the 4th times, how many j's will get me to the j to the 9th? J to the 5, right? So j to the 5th power. And then of course, we need that k to the 7th as well. K to the 7th right there. And then the last one, 9 times what is positive 18? That'd be a positive 2. And then j to the 4th times what gets us j to the 4th? We don't need to do anything because it's like if we put a 1 right there, it wouldn't change anything. So this is your final factored form answer. Let me rewrite it though. 9j to the 4th was on the outside. Let me get it closer to the parenthesis. 9j to the 4th. And then that's what's left over on the inside. And that is completely factored. There's nothing else to do. Let's move on to the next one. Simplify. This is super easy. All we're doing is distributing and then combining like terms. So let's distribute the 3c first. 3c times 3c is 9c squared. 3c times positive 3, that's positive 9c. But then when we distribute this term, the negative 3 times 3c, that's negative 9c. And negative times positive 3, that's a negative 9. So what ends up happening is our middle terms, the positive 9c and the negative 9c, cancel out. So yes, our final answer is 9c squared minus 9. That is our final answer for number, what is this? 35. So that's the answer for 35. Let's move on to 36. We're almost done with this thing. 36, find the coordinate of the vertex. Once again, this is in standard form. It's not in vertex form. So if it's in standard form, we should remember to find the vertex, we need the formula x equals negative b over 2 times a. And you need to know how to use the formula. X is going to equal negative b in parentheses instead of b over 2 times a with parentheses instead of a. So let's identify the a value is 1, the b value is negative 3, the c value is 2. Let's plug in the b value of negative 3, the a value of 1. Okay, so this is going to be ugly because the b value is not an even number. It's an odd number, which means we're going to end up having to deal with the fraction. You see, the minus minus changes to plus plus. 2 times 1 is 2. So we really have the x value being 3 over 2. So we could leave it 3 halves as the x value of the vertex, or you could write it as 1.5, whatever you want. Okay? Now, if you know your x value and you want your y value, what do we do? Plug it in. So Andrea, pay attention. We're going to plug in the 3 halves into the function. So we're going to rewrite it. Y equals x squared minus 3x plus 2. And we could plug in 3 halves and 3 halves. And you could actually do all this with a calculator. Okay? Or if you prefer, you could change that 3 halves to a decimal. What is 3 divided by 2? It's 1.5. So if you wanted to, you could plug all this in with 1.5. I'm sorry, 3 divided by 2 is 1.5. You could plug in a 1.5, and then you could work it out on the calculator, and it will give you your answer. Let me show you how you could work it out on the calculator. So as you can see right here on the calculator, you could type it all in, and instead of the 3 halves, I typed in 1.5 because 3 divided by 2 is 1.5. $3 divided by 2 is $1.50. So if you type it all in, as I did right here with parentheses, exactly the way it is, hit equal, it'll give you negative 1/4 as the output. Now, I could do all this and get that output of negative 1/4 without the calculator. Would you guys like to see how I get the negative 1/4 without the calculator? Sure, why not? Okay, so let's do the exponent first. What's 3 halves squared? That's really 3 halves times 3 halves. So if I write that out, 3 halves times 3 halves, what's 3 times 3 and what's 2 times 2? You end up with 9/4, yeah? And then over here, put the 3 over a 1, and 3 times 3 is 9, and 1 times 2 is 2, so you get minus 9 over 2. And of course, at the very end, you have the plus 2. Now, in order for you to add these two fractions, you need a common denominator. So let me move it to the side. That common denominator will be 4. And there's a minus sign between them. So the 4 is already 4, so the 9 is going to stay the same. That'll be a 9 up there. And then this 2 is going to become a 4 by multiplying by 2 and multiplying by 2. And you really end up with an 18 over 4. Let's not forget about the plus 2 at the very end. So 9 minus 18, now that we have a common denominator of 4, I could actually do 9 minus 18. We will get negative 9 over 4 and then plus 2. So negative 9 over 4, if we think about that, that'll go in 2 times, and you'll have a remainder of 1 left over. So that's really negative 2 and 1/4. So let me rewrite that. This is really negative 2 and 1/4 plus 2. So if you have negative $2 and a quarter, if you owe somebody $2.25 and you have $2, you're still going to owe them the 1/4 of a dollar, the 25 cents. So that's how we get the output of negative 4. So the vertex is 3 halves and negative 1/4. Or you could say that the vertex is 1.5 and negative 1/4. Number 37, it says one of the factors. Okay, so we need to factor this quadratic trinomial equation, and the way to do that is because the a value is 1, right? There's no number in front of the x squared. You could put an x here and an x there. Then you simply think what times what is negative 24, that if you combine together is negative 2. If you don't see it right off the bat, go ahead and make a list. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Those are all the possible multiplications that combine together, that multiply together to give you a negative 24. And out of those pair of numbers, which pair of numbers combines together to give you the negative 2 in the middle? That would be negative 4 and 6, but you have to change the signs, because if you leave it negative 4 and 6, so you combine it, it gives you a positive 2, and we know we want a negative 2. So we have the right number, we just have the wrong signs. So make that a positive 4 and a negative 6. So you put the plus 4 in there and the minus 6 right there. Now that is the answer. This is the factored form. But notice how the question is asked. It says one of the factors of this is either A, B, C, D, or none of the above. So C is incorrect because it says x minus 4, and we just said that it's actually x plus 4, right? So that's kind of tricky, right? So it's really none of the above. So be very careful with that, guys. The correct answer is none of the above, because one of the factors is either x plus 4 or x minus 6, and none of those binomials are provided as multiple choice answers. Let's move on to number 38. Let's graph this quadratic trinomial. And this quadratic trinomial is in standard form. So we need to walk through it, finding the vertex first. And in order to find the vertex, which is a coordinate, we want to use the formula x equals negative b over 2 times a. And when we use the formula, we want to use parentheses replacing the letters. So negative parenthesis over 2 times parenthesis. Let's identify the A value, which is -1, the B value, which is 2, and the C value, which is 3. Let's plug in the B value right here and the A value of -1 right there. So our x of our vertex is really -2 over -2, and -2 divided by -2 is what? 1. And if we have the x value of 1 and we want the y value, what do? Plug it in. So I'm going to go and zoom in to this f of x function, and I'm going to plug it into the x values. So the first thing to do would be to rewrite it with parentheses. Instead of -x squared, you put negative parentheses squared. Instead of plus 2x, 2 times parentheses, and then plus 3 at the very end. Now we said we are plugging in that x value of the vertex, which is 1. We found that out with the formula. And now we're going to actually work through this using PEMDAS. So we're going to begin with exponents, and this is just 1 squared, which is 1. So we really have a negative in front of that 1. And then we have, after exponents, 2 times 1, which is just 2, and then plus 3 comes down. So we finally have just addition and subtraction. -1 plus 2, that's if you owe $1 and you have $2, you're still going to have $1 left over. So this is just $1. And then plus 3, your final answer is 4. So the y value of your vertex is 4. The x value is 1, the y value is 4. Let's go to the coordinate 1 and 1, 2, 3, 4, put a dot right there. That's our vertex. Now we are going to draw an axis of symmetry right through that vertex value. And the A value is what? The A value is -1, which means we can use the pattern 1, 1, 2, 4, 3, 9 without having to modify it. And the negative sign in front of the 1 is telling you that it's opening down. So with the pattern, you're going to go 1 over 1 down. 1 over 1 down, and let's put a dot right there. And then you go back to the vertex, and you go 2 over 1, 2, 3, 4 down, and put a dot right there. Then you go back to the vertex and go for the last one, 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's put a dot right there. And of course, we have that axis of symmetry, so we could reflect the coordinates over to the other side. It's 1 unit away, so go 1 unit this way and put a dot right there. This guy is 2 units away from the axis of symmetry. Go 2 units this way and put a dot right there. Whoops, right there. And then the last one, it's 3 units away. So go 3 units away this way, put a dot right there. Connect the dots, and you have your perfect parabola that opens down. Now, number 39, the last one. Find the difference. So difference means subtract. Guys, when I asked you to add, nothing changed. You just combine like terms. But you have a minus sign right here. And we do need to distribute this minus sign to each and every term. So it really just changes the signs. That q squared becomes negative q squared. The negative 9p becomes plus 9p. The plus 3p squared becomes negative 3p squared. And the first parenthesis, there's nothing to distribute, so you just rewrite it. And now all we have to do is combine like terms. So let's start with the highest exponent term, the p squared. By the way, there's p's and q's, so you want to go in alphabetical order. Start with p first and with the highest exponent, so that's negative 3p squared. That's the first part of your answer. And then you want the other squared term, which is the q. So we have a negative 2q squared right there and a negative q squared. So if you owe somebody $2, you owe them another $1, you're going to owe them a total of 3 of those dollars. In this case, q squares. Then we go back to the p's, and we're going to go with 13p added with 9p, and that becomes 22p. And then last but not least, we have the minus q right here. So let's just slap that on at the end, minus q. So there is your answer for this last question on the practice final. And that's all you need to know.